based on different types of vectors. Now again to solve some more problems. Now here there is most important problem, 2 mark question they will ask in final exam. If magnitude of a plus b is equal to magnitude of a minus b, then prove that a and b are perpendicular. Both the vectors are perpendicular. As you know that if two vectors are perpendicular, condition a dot b is equal to 0. Now here given data, magnitude of a plus b is equal to magnitude of a minus b. Now to prove a and b are perpendicular. Now what can you do? Squaring on both sides. What happens? Magnitude of a plus b to the power of 2 is equal to magnitude of a minus b to the power of 2. Squaring on both sides. Now usual algebraic expansion. As you know that a plus b whole square formula, that is a square plus b square plus 2ab. Here we can write magnitude of a to the power of 2 plus magnitude of b to the power of 2 plus 2 into a dot b is equal to, again a minus b whole square formula, magnitude of a to the power of 2 plus magnitude of b to the power of 2 minus 2 times a dot b. Then simplify magnitude of a to the power of 2 plus magnitude of b to the power of 2 plus 2 times a dot b. Take equal on right side. Magnitude of a minus magnitude of a to the power of 2 minus magnitude of b to the power of 2 plus 2 times a dot b is equal to 0. Plus magnitude of a square minus magnitude of a square cancel plus b square minus magnitude of b square cancel, 2 times a dot b plus 2 times a dot b, that equals 4 times a dot b is equal to 0. So that divide both sides by 4, so that a dot b is equal to 0. If a dot b is equal to 0, conclusion, hence vector a perpendicular to vector b. Two vectors are perpendicular. A is equal to, if a is the vector, that is 2i plus 2j plus 3k, 2i plus 2j plus 3k. B is the vector is equal to minus I plus 2j plus k, minus I plus 2j plus k. Okay? And C is the vector 3i plus j, 3i plus j. Totally 3 vectors are given. Now here the question, A, B, C 3 vectors are such that A plus lambda b, A plus lambda into b, where lambda is constant, is perpendicular to vector C. Then find the value of lambda. Then find the value of lambda. If 3 vectors are given such that one vector is perpendicular to another vector. Now here a plus lambda b is perpendicular to C. Using this, since a plus lambda b perpendicular to C, now put a plus lambda b, call it as alpha vector. Now clearly alpha vector is perpendicular to C. Again you know that if two vectors are perpendicular, condition alpha dot c is equal to 0. Alpha means a plus lambda b dot c is equal to 0. Now using this, simplify to find the value of lambda. Now here a plus lambda b. What is a vector? 2i plus 2j plus 3k plus lambda of b vector minus I plus 2j plus k into C dot C. C vector is 3i plus j is equal to 0. Now simplify. 2i plus into minus minus lambda I. From these two I common, 2 minus lambda into I. 2j plus 2 lambda j common, 2 plus 2 lambda into j, 3k plus lambda k common, 3 plus lambda into k, dot 3I plus j, there is no k term, we write 0 into k is equal to 0. In between these two dot product, definition of dot product, multiplying the corresponding elements, coefficient of I, here 2 minus lambda, here coefficient of I 3, plus coefficient of j 2 plus 2 lambda, here coefficient of j 1, a1, a2 plus b1, b2 plus c1, c2, coefficient of k 3 plus lambda, here coefficient of k 0 is equal to 0. Simplify. 2 into 3 6 minus 3 lambda plus 2 plus 2 lambda plus 3 plus lambda into 0, 0 is equal to 0. Rearrange. Minus 3 lambda plus 2 lambda, that is minus 1 lambda. 6 plus 2 plus 8 is equal to 0, therefore lambda is equal to plus 8. Find the value of lambda so that a plus lambda is perpendicular to c, then lambda value is 8. Minus a dot x plus a is equal to 12. Important problem, 2 mark question. Very simple problem. To find magnitude of x for a unit vector a is unit vector, using this to solve x minus a into x plus a is equal to 12. Now how to solve? Given x minus a dot x plus a is equal to 12 implies usual algebraic expression, as you know that it is in the form a minus b into a plus b form. As you know that a minus b into a plus b formula, a square minus b square, here x square minus a square is equal to 12. A minus b into a plus b formula, a square minus b square, instead of a and b here, x minus a into x plus a, x square minus a square, implies mod x, magnitude of x to the power of 2 minus magnitude of a value, because unit vector is a is unit vector, definition of unit vector whose magnitude become 1 is equal to 12, because definition of unit vector magnitude of a is 1. So this implies magnitude of x to the power of 2 is equal to 12. Transfer it, minus 1 goes to right side, plus 1, that is 13. Therefore magnitude of x is equal to root 13. So that sum of 3 vectors is equal to 0. Find the value of a dot b plus b dot c plus c dot a. Now given a, b, c are unit vectors, definition of unit vector whose magnitude become 1. Magnitude of a is 1, magnitude of b is 1, magnitude of c is 1, and sum of 3 vectors is equal to 0. Using this to find a dot b plus b dot c plus c dot a. Now given a plus b plus c is equal to 0. Now taking magnitude on both sides. So magnitude of a plus b plus c is equal to magnitude of 0 is 0. Now squaring on both sides. Therefore squaring on both sides, what happen? A plus b plus c, magnitude of a plus b plus c to the power of 2 is equal to 0. Now usual algebraic expansion, a plus b plus c whole square formula, magnitude of a square plus magnitude of b square plus magnitude of c square, a plus b plus c whole square formula, a square plus b square plus c square, plus 2 times a dot b plus 2 times b dot c plus 2 times c dot a, take 2 common, 2 into bracket a dot b plus b dot c plus c dot a is equal to 0. This implies, but magnitude of a value 1, 1 square 1, magnitude of b is 1, 1 square 1, magnitude of c is 1, 1 square 1, plus 2 times a dot b plus b dot c plus c dot a is equal to 0. Now this implies rearrange 2 times a dot b plus b dot c plus c dot a is equal to 1 plus 1 plus 1, 3. 3 goes to right side, minus 3. Now divide by 2, we get A dot B plus B dot C plus C dot A is equal to minus 3 divided by 2 is the answer. In annual exam there is 3-mark question. Now listen, here if A, B, C be 3 vectors such that magnitude of A is 3, magnitude of B is 4, magnitude of C is 4 and each one of them being perpendicular to sum of other two. Now here totally 3 vectors are given, namely A, B and C. Now here given magnitude of A is equal to 3. Magnitude of B is equal to 4 and magnitude of C is equal to 5. Each one of them being sum of other two. Total 3 vectors A, B, C. Each one of them is perpendicular to sum of other two. Suppose if you take A vector, A is perpendicular to sum of other two, B plus. If you take B vector, B is perpendicular to sum of other two, A plus. If you take C vector, C is perpendicular to sum of other two. Now take one by one. Now first you take vector A is perpendicular to sum of other two, B plus. Then vector B vector B is perpendicular to sum of other two, C plus. And vector C is perpendicular to sum of other two, A plus. Implies here vector A is perpendicular to B plus C. Put B plus C is equal to say alpha vector. Then what happens? Vector A is perpendicular to alpha. You know that two vectors are perpendicular condition. What is the condition? Dot product is equal to 0. A dot B plus C is equal to 0. Now this implies, remove that dot product, A dot B plus A dot C is equal to 0. Equality equation 1. Next, vector B is perpendicular to C plus A. Again, definition of dot product. Condition for two vectors are perpendicular. B dot C plus A is equal to 0 implies, remove that bracket, B dot C plus B dot A is equal to 0. Equation. Similarly, vector C is perpendicular to A plus B implies C dot A plus B is equal to 0 implies, remove that bracket, C dot A plus C dot B is equal to 0. Equation 3. Okay. Now add these 3 equations. What happened? Therefore, add these 3 equations. Equation 1 plus equation 2 plus equation 3 gives. See what happened? A dot B plus A dot B. B dot A is same as A dot B. A dot B plus A dot B. 2 times A dot B. A dot C plus A dot C. 2 times A dot C. B dot C plus B dot C. 2 times B dot C. That is 2 common. A dot B plus B dot C plus C dot A is equal to 0 plus 0 plus 0. 0 plus 0 plus 0. 0. Now to find magnitude of A plus B. Now consider magnitude of A plus B plus C whole square. Squaring is equal. What is the formula? Magnitude of A to the power of 2, usual expansion, plus magnitude of B to the power of 2 plus magnitude of C to the power of 2. 2 times A dot B plus B dot C plus C dot B. As you know that A plus B plus C whole square formula, A square plus B square plus C square plus 2AB plus 2BC plus 2CA 2 common, A dot B plus B dot C plus C dot B. Now this is that is equal to magnitude of A is given 3 square 9, magnitude of B is 4 square 16, magnitude of C is 5 square is 25 plus 2 times A dot B plus B dot C plus C dot A using equation number 4. What is that? 2 times A dot B plus B dot C plus C dot A value? 0. Now that is magnitude of A plus B plus C to the power of 2 is equal to 9 plus 16, 25 plus 25, 50. Now taking the square root on both sides, magnitude of A plus B plus C is equal to root 50. Root 50 can be written as 25 into 2, that is 5 root 2 is the value of magnitude of A plus B plus C. Okay. Now next problem based on cross product. The magnitude of A cross B. If A is the vector 2i plus j plus 3k, vector B is equal to 3i plus 5j minus 2. Now here there is 2 mark question. First to find A cross B vector. Cross product of two vectors, you know the formula. That is A cross B is equal to, what is that formula? Determinant I j k first row. Second row, coefficient of I eigen vector A 2, 1, 3. Right? Coefficient of I eigen vector B 3, 5, minus 2. Expand that determinant. That is equal to I into deleting first row, first column. 1 into minus 2, minus 2. Minus 5 3s are 15. Minus j into deleting first row, second column. 2 into minus 2, minus 4. Difference minus 3 3s are 9, plus k into deleting first row, third column, 2 5s are 10, minus 3, that equals minus 2 minus 15 minus 17i, minus 4 minus 9 minus 13 minus into minus plus 13j, 10 minus 3 plus 7k. This is A cross B. Now the question, find magnitude of A cross B. Magnitude, that is under root of coefficient of I minus 17, minus 17 square 289, coefficient of J 13 square 169, coefficient of K 7 square 49. How much? 9 plus 9 18 plus 9 27, carry 2 6 12 plus 8 20, carry 2 3 plus 2 5. Root 507, correct? Root 507, correct? Similarly, second problem, same type. First to find A cross B vector. Definition of cross product, determinant I j k, coefficient of I j k vector A 1 minus 7 7, vector B 3 minus 2 2. Expand that determinant I into deleting first row, first column, minus 14, the difference of the cross multiply, minus 2 into 7 minus 14, minus into minus plus 14, minus j into deleting first row, second column, 1 into 2 2, difference minus 3 7s are 21, plus k into deleting first row, third column, minus 2, difference minus 3 into minus 7 minus 21, minus into minus plus 21, that equals minus 14 plus 14 cancel, that is 0 into I, 2 minus 21 minus 19 minus into minus plus 19j, minus 2 plus 21, again 19 plus 19k. So that is take 19 common, j plus k, right? Therefore, magnitude of A cross B is equal to 19 into root of coefficient of j 1 square 1, coefficient of k 1 square 1, that is 1 plus 1, that is 19 root 2 is the value. Again 2 more question, find the unit vector perpendicular to both the vectors. So you know the formula. What is that? Unit vector perpendicular to both the vectors is denoted by n cap is equal to, remember, A cross B divided by its magnitude, magnitude of A cross B. Now first to find A cross B. How to solve A cross B? Definition of cross product. Determinant I j k. Coefficient of I j k in vector A 3 1 minus 2. Coefficient of I j k in vector B 2 3 minus 1. Plus minus plus. Expand I into deleting first row, first column. 1 into minus 1 minus 1, the difference of the cross multiply, minus into minus plus 3 2s are 6, minus j into deleting first row, second column, minus 3 minus the difference of the cross multiply, 2 into minus 2 minus 4 minus into minus plus 4, plus k into deleting first to third column, 9 minus 2, that equals 5i minus 3 plus 4 plus 1, 1 into minus 1 minus j, 9 minus 2 plus 7k. This is A cross B. Then to find its magnitude, magnitude of A cross B is equal to under root of coefficient of I 5 square 25, coefficient of j minus 1 square 1, coefficient of k 7 square 49, that is root of 49 plus 1 50, 50 plus 25 75, that 75 can be written as 25 into 3, that is nothing but 5 root 3. Therefore unit vector perpendicular to both the vector n cap is equal to A cross B. A cross B value 5i minus j plus 7k divided by its magnitude 5 into root. That's it. Another example, if A is the vector 4i plus 3j plus k, 4i plus 3j plus k, and B is the vector I minus 2k, I minus 2k, here there is no j term. Now the question, find magnitude of 2b cross a. Find magnitude of 2b cross a. Now first to find 2b. Now here 2b is equal to 2. B vector is I minus 2k. That is equal to, remove that bracket, 2i. There is no k term. We can write 0 into j, right? 2 into minus 2k minus 2. Now to find the first part 2b cross a. In between these two cross product, definition of cross product determinant ijk, then coefficient of ijk in vector 2b, 2 0 minus 4, vector a 4 3 1. Expand that determinant, that is I into deleting first row first column, 0 minus into minus plus 4 3s are 12, minus j into deleting first to second column, 2 minus 4 into minus 4 minus 16 minus into minus plus 16, plus k into deleting first to third column, 2 3s are 6, minus 4 into 0 0, that is 12i plus 18j plus 6k. Among these three, I think common 6 common, 2i, right, plus 3j plus 1k. This is 2b cross. Then to find magnitude of 2b cross, that equals 6 into under root of coefficient of I 2 square 4, coefficient of j 3 square 9, coefficient of k 1 square 1, that is 6 into root 14. 2 mark question. Most important, that is 2 mark question. They will be asked in final exam, represented by the vectors. First problem, vector A is equal to I minus j plus 3k, I minus j plus 3k. Vector B is equal to 2i minus 7j plus k, 2i minus 7j plus k. Second one more problem. Vector A is equal to 3i plus j plus 4k, 3i plus j plus 4k. And vector B is equal to I minus j plus k, I minus j plus k. Each question carries 2 marks. So first one, find the area of parallelogram with the 2 adjacent sides are given. You know that area of parallelogram with the 2 adjacent sides A and B is given by the formula. What is area of parallelogram? That is magnitude of A cross B. Now here first to find A cross B, first problem. Now A cross B is equal to, definition of cross product determinant ijk, coefficient of ijk in vector A 1 minus 1 3, vector B 2 minus 7 1. Expand it. I into deleting first column minus 1 plus 20 minus j into first row second column 1 minus 6 plus k into deleting first row third column minus 7 plus 2. That is minus 1 plus 21 plus 21 plus 5j minus 5. Now take 5. Now A cross B is equal to definition of cross product, determinant I j k, coefficient of I j k vector A 1 minus 1 3, vector B 2 minus 7 1. Expand it after simplification 20i plus 5j minus 5k. Take 5 common, 4i plus 1j minus k. Then to find its magnitude of A cross B. Therefore, magnitude of A cross B is the value of area of parallelogram is equal to magnitude of A cross B. It is 5 into under root of 4 square 16, coefficient of K 1 square 1, coefficient of K minus 1 square 1, that is 5 root 18. Further, root 18 can be written as 9 into 2, root 9 is 3, 3 5s are 15, root 2 is the value of area of parallelogram. Okay. Similarly, second one same thing. Area of parallelogram with two diagonals are given. Area of parallelogram with diagonals. Again, two more questions. Diagonals are represented by the vector A is equal to 3i plus j minus 2. 3i plus j minus 2. B is equal to vector B is equal to, that is I minus 3j plus 4. Diagonals are given. Now here diagonals denoted by D1 and Todana. Let D1 is the vector 3i plus j minus 2 and D2 is the vector I minus 3j plus 4. These two are diagonals. You know the formula. Area of parallelogram with two diagonals given by the formula 1 by 2 into magnitude of D1 cross D2. 1 by 2 is the area of parallelogram with adjacent sides. By taking 1 by 2, that is the area of parallelogram with two diagonals. Now first to find D1 cross D2. How to solve D1 cross D2? Definition of cross product, determinant Ijk, coefficient of Ik and vector D1 3 1 minus 2, vector D2 1 minus 3 4. Expand that determinant, that is I into deleting first row first column 4 minus 6 minus j into deleting first row second column 12 plus 2 plus k into deleting first row third column minus 9 minus 1 4 minus 6 minus 2i 12 plus 2 14j minus 9 minus 1 minus 10k. Among these three take 2 common, minus I minus 7j minus 5. Then to find its magnitude of D1 cross D2 is equal to 2 into under root of coefficient of I minus 1 square 1, coefficient of j minus 7 square is 49, coefficient of k minus 5 square is 25, that is 2 into root how much 75, that is 2. 75 is same as 25 into 3, square root of 25, 5 into root 3, that equals 10 root 3. Therefore, area of parallelogram with diagonals is given by the formula 1 by 2 into magnitude of D1 cross D2, that is 1 by 2 magnitude of D1 cross D2 value 10 root 3, 2 1s are 2 5s are, that is 5 root 3 is the answer. 3 more question. Using vector method, find the area of triangle with 3 vertices are given, A vertex, B vertex, C vertex. You know the formula. What is the formula for area of triangle with 3 vertices? Is given by the formula. Do you remember? What is that? 1 by 2 into magnitude of AB cross AC. Remember, if 3 vertices are given, area of triangle with 3 vertices is given by the formula 1 by 2 into magnitude of AB cross AC. Now here first problem. 3 points are given. A point 112. B point 235, C point 155. Points are given. To convert points into position vector. Now here A is the point 112. What is position vector? A is the point 112. Position vector denoted point. OA is equal to 1I plus 1J plus 2K. Then position vector OB is equal to B is the point 235. That is 2I plus 3J plus 5K. C is the point 155. Position vector OC is equal to 1I plus 5J plus 5K. Now to find the area of triangle with 3 vertices is given by the formula 1 by 2 magnitude of AB cross AC. Now to find AB vector using position vector, AB vector can be written as OB minus OA. Subtract OB minus OA. 2I minus I. 1I, 3J minus J plus 2J, 5K minus 2K plus 3. This is A. Next, to find AC vector. AC is equal to OC minus OA using position vector. OC minus OA. 1I minus 1I cancel 0I. 5J minus J plus 4J. Then 5K minus 2K plus 3. We got AB vector and AC vector. In between these two cross product. Now to find AB cross AC. Now vector AB cross AC. You know the definition of cross product. Determinant Ijk. Coefficient of Ijk in vector AB 1, 2, 3. Vector AC 0, 4, 3. Plus minus plus. Expanding. I into deleting first column. 6 minus 12 minus A into deleting first to second column 3 minus 0 plus K into deleting first to third column 4 minus 0. That equals 6 minus 12 minus 6 on minus 3J plus 4. This is AB crosses. Then to find its magnitude of AB cross AC is equal to under root of minus 6 square 36, minus 3 square 9, 4 square 16. How much? 36 plus 16, 52. Right? Plus 9, 61. Therefore, area of triangle ABC is equal to formula 1 by 2 into magnitude of AB cross AC. That is 1 by 2. Magnitude of AB cross AC is root 61 square units. That is 3 mark question.